Hello, everyone, and welcome to our session. We're really glad that you're able to join us to talk a little bit about how Amazon.com uses AI and generative AI and models to enhance shopping for our customers. My name is James Park. I'm a Senior Solutions Architect with AWS.
My name is Belinda Zing. I lead large-scale foundation model work at Amazon.
Hello, folks. I'm Vijay. I'm a principal engineer at Amazon.
Thank you all. And as you all get seated, let's get right into it. So we're going to talk for about 45 to 50 minutes, and then we'll open it up for some question and answers, should you have any questions. So for the session, we'll talk a little bit first about the background of ML at Amazon. We'll talk a little bit about the challenges of building and deploying foundation models. Then Belinda's going to come up and give you a real good glimpse into what their team is doing for Amazon as a whole. If you watched Swami's keynote this morning, you may have gotten a glimpse of some of the things that we're doing with image generation, and you'll get to see the team that's behind that. After that, Vijay is going to come up and give you an in-depth look behind the scenes of what AWS services we use to build and deploy the models that we do at scale. So with that being said, I thought it'd be great to first talk a little bit about the history of ML at Amazon. Now, for many of you, it may be pretty well known that Amazon started in 1997 with the launch of our website, Amazon.com. What you may not know is that machine learning started shortly after that in 1999, where our first ML models were deployed and used for book recommendations. Now, over the decades, obviously, ML has expanded greatly, and the scale of Amazon.com has expanded greatly as well. In 2023, over 1 in 3 e-commerce purchases were made on Amazon.com. 4,000 products are sold every minute on Amazon.com, which results in 1.6 million packages shipped every day. Not only that, but obviously we have ancillary services like Alexa, which handles billions of interactions every week. And again, ML is prolific throughout everything that we do. It is responsible for supporting over 400 million products that we forecast every day. It is deployed in over 150 countries across the globe. And we power many of the things that we use for our infrastructure, including our fulfillment centers, the robots that carry items from place to place, and the 30,000 delivery vans that carry our packages to our customers every single day. Now, you may be familiar with this experience as well as I am. As a customer, I go to Amazon.com, I choose a product, usually purchase that product, and then behind the scenes, Amazon packs it and ships it to me, and it arrives on my doorstep. This screen may be familiar to some of you. I know I browse it pretty much daily. I use the search bar prolifically, and Belinda's going to talk a little bit about the technology that goes behind powering that experience. In addition, I'm an Amazon Prime subscriber, so I get to watch Amazon Prime content. The recommendations that we list on the front page are driven by ML, and even the products that are recommended for me to purchase are recommended by ML. As it is probably for you, these recommendations are scary accurate, and I often find myself clicking and purchasing the things that are recommended. Now, after I've purchased something, that package, or the process of fulfilling that package, goes into full motion. Our Amazon warehouses process millions of packages every day, and you might be surprised to know that there are over 10 miles and conveyor belts that move your package from one place ultimately to that delivery truck. We use ML to do things like package damage detection so that we can make sure that those packages arrive to our customers in the best quality possible. In addition, we use services like AWS Monitron to make sure our own conveyor belts have the proper maintenance done on them before they break down and impact our operations. Now, once our packages have moved through that fulfillment center, it gets loaded on a truck. And even before that truck leaves our fulfillment centers to deliver that package to our customers, we've already used ML to generate routes for our trucks, so our drivers know the optimal route to drive for the best performance in terms of speed to our customers and gas savings and other efficiencies throughout the entire globe. If everything goes well, that package arrives at your doorstep, and ultimately, we hope to see happy customers. But again, ML is prolific throughout Amazon, and generative AI has hit the world by storm. We use generative AI across all of our businesses. So you may be familiar with our seller fulfillment network, where sellers can list their products on Amazon.com. And recently, we launched the ability for sellers to come to our website, list the products that they want to sell, and our generative AI models behind the scenes will actually generate a product description for them, saving them tons of time. If I have 100 products, I surely don't want to write 100 different product descriptions. And this way, we give sellers a head start so that they can list those products faster and with great ease. Now, you as a customer probably use things like the website, Amazon.com, or your mobile device. And we also launched a new feature that helps you sort through all the reviews that other customers have posted on Amazon.com and do a summary for you. Let me give you an example. I often try to go do a lot of research before I buy something. And if I'm buying a new LCD TV or something of that sort, I will sit there and read through the hundreds of reviews before I click that purchase button. I don't have to do that anymore because we have an AI model behind the scenes that reads all 100 reviews for you and then provides a single, simple summary that reflects the entire aggregate of what customers have provided. It also tags certain key points that may be of interest to me, such as the ease of use that people have cited when using that product. But again, these generative AI models directly benefit our customers. And lastly, we use generative AI to benefit ourselves. If you're familiar with our Amazon Palm device called Amazon One, it allows you to walk into stores such as Whole Foods and just use your palm to purchase anything that you have selected within the store. As you might imagine, we need to make sure that those devices are very accurate and respond well so we provide a delightful experience to our customers. Instead of going out and taking pictures of all your hands out there, what we did actually was used a generative AI model to generate those images beforehand and use that in the process that we used to build, develop, and test our devices. Now, as you might imagine, at Amazon's scale, this is really hard to do. When we're talking about generative AI, we're talking about deep learning or neural network models, and they, quite simply, can be very large in size, often exceeding billions of parameters. They may require one or many accelerators, and again, at Amazon scale, that can result in a cost that far exceeds what you really want to be investing into your generative AI use cases. But we need to make sure our infrastructure is optimized for efficiency and utilization, and make sure that we're doing our best to optimize for cost so that we can maintain low prices for our consumers. Lastly, we always start with the customer, and the performance of these models is inherently important for our customer experience. If a customer is going through a process, such as they check out of purchasing something on Amazon.com, we don't want them to sit there for seconds or minutes waiting for their process to complete. Those processes need to happen in milliseconds. And so we ultimately need to make sure that we have the right combination of size in determining what we use for our hardware, our cost optimization strategy, and ultimately making sure that our customers have what they need to have a pleasurable experience. Now, it may be no surprise, but all that stuff happens on AWS. And within AWS, there's a host of ML services available. You might look at services up the stack, such as Comprehend, where you do not need a single data scientist to benefit from AI capabilities. And then further down in the stack, you'll see our ML frameworks and infrastructure layer, where the world is your oyster. You can choose all the pieces that you want to have fine-level granularity in building the ML platform that supports your business. You can see down there some Amazon silicon in the form of Trainium and Inferentia. These are great cost of performance options with VJ, which we'll get into. And with that being said, I want to make it clear, Amazon uses machine learning prolifically. And at scale, it's really important to not only build these models properly for performance and accuracy, but also train and deploy them with efficiency in mind. So with that being said, I'd love to give you a look at what one of our awesome teams in Amazon is doing. So please welcome Belinda to the stage.
Hello, everyone. Hello again. I hope you are still enjoying this presentation. Like what I shared before, my team focused on building large-scale foundation models at Amazon. Our goal is to try to change the way deep learning systems are built and deployed across the company. And by doing that, we would like to lift all the Amazon services beyond the current state of art, and meanwhile unblock many new downstream applications. So our core products are called semantic representations, and we build that for key e-commerce related entities, such as the products that you and me purchase on Amazon.com, or the queries we type when we try to do the product search, when we try to make our purchases. What the semantics mean in this context is our focus is try to capture the meaning of the data, leveraging the large language model technology, instead of simply matching the exact keywords. Why that is important is it essentially leveraging a data-centric approach to help us effectively represent the real-world entity, and in the end, conceptualize those entities explicitly. There are many literature, there are many studies have shown that it can help improve the performance greatly for many machine learning applications. So get well-performing semantic representation requires massive diverse data set, which actually are plentiful here at Amazon. So here, I want to show you one example on the right-hand side of the screen. So this is a sample page of a product detail page when you go search product on Amazon. So on the product detail page, we are able to see the product title, description, bullet points. We can see the customer reviews, the product rating, the pictures of the products, and many of them have videos, right? So there are rich, vast amount of product information, and we have billions of product page like this. So that's our data assets. So give us this opportunity to build and pre-train this large-scale foundation model that leverage hundreds of billions of rows and scale up to hundreds of billions of parameters. Well, for semantic representation, we have identified 5 key pillars that can help making our model more relevant to the e-commerce business. So the 5 pillars are multi-model, multilingual, multi-locale, multi-task, and multi-entity. So first and foremost, we have to build a model which are multimodal because Amazon data are available in multiple modalities. Just imagine what we just saw on the product information page. There are unstructured text information, structured tabular data for product specs. Most products have images, and many of them have associated videos. So we really would like to capitalize on top of this vast amount of diverse information. Our model also multilingual because Amazon sells products in several dozens of countries. Meanwhile, a lot of those product informations have to be specialized in the locales in which it is sold in order to take account for the cultural differences. That means our model also have to be trained on data from multiple locales. Furthermore, we also leverage multitask learning to train on top of a diverse set of Amazon tasks, like what James just shared a few. Because in the end, we would like to make sure all the machine learning teams can make use of our model to solve different types of customer problems. Lastly, an equally important component is multi-entity, because we would like to capture the relationships between different important entities. For example, what kind of queries customer normally type to search what the type of products sold by which seller, right? In order to answer this kind of questions actually can help our e-commerce business greatly, so that we really want to build our foundation model leveraging those relationships on top of multiple entities. Well, so that's the 5 key pillars for our semantic representation. As a matter of fact, my team is called Search M5, and that is my team's name come from. A quick summary about the business impact we have made in the past 3 years since we first established in Q4 2020. So for the past 3 years, we have successfully launched, onboarded 500 applications utilizing our model, among which more than 130 applications have seen significant improvement of their performance. That helped driving more than 50 application launches. These launches altogether collectively has contributed billions of dollars of incremental sales and contributed to hundreds of millions of cost savings in our operation. Not only that, a lot of those launches also try to eliminate or at least reduce the defect in the Amazon shopper journey. So we are very proud of that accomplishment. So today, I'd like to share some of the models we have developed over the past years and how they helped to transform the Amazon shopper journey. The first example I'd like to talk about is spelling correction. Amazon search vision is to help the customers search on Amazon effortlessly. So spelling correction is a feature to help anyone search what you want without even knowing the exact spelling of the intended word. Historically, the spelling correction team, they leverage the classical machine learning algorithms on top of intensive manual feature engineering to do this job. It is time consuming, and also there is a cap for the performance. So we work closely with the application team. We explore together a number of deep learning approaches, including a sequence-to-sequence generative modeling architecture that we built. It is a state-of-art large language model architecture, and we proved it performed really well through offline and online experiments. So after launching this online, we see significant improvement in the customer experience. Not only that, our contribution also demonstrated in a multilingual, because we do not just want to see improvement in the US, we also want to see our model excels in all the primary languages across all the major Amazon marketplaces. So therefore, we build our foundation model on top of a diverse, large, multilingual data set that help us achieve our goal. A second example is AI-generated product images. Here, we would like to generate an image of a bathroom with a specific setup, including furniture, accessories, etc. A key phrase in the prompt is wooden ladder shelf, which is a common product type here we sell on Amazon. As we can see on the comparison of the two rows, the bottom are the images generated from our in-house model. And you can see the wooden ladder shelf can be shown across all images. Compared to that, the top row are the images generated from the public open source model. And we can see it cannot generate the focused products in all images. What that means is this example highlights how in-domain training on top of our Amazon catalog data can help us produce this output images that's more closely aligned with the product focus use case that we are looking for. Related to this, there's another work stream we have been invested this year in contextualizing synthetic lifestyle image. Lifestyle image are really critical. They play a key role, especially when customers come to Amazon exploring in visual categories, including home and furniture. Historically, the good photography could play a good role generating good selections. However, this approach is time-consuming and costly. So it is equally important to develop machine learning technology to synthesize lifestyle product image with very little or no human involvement. So in this example, we would like to contextualize some focused product image with this white background. So on the several prompts on the right-hand side of the slide, each of them specifies specific setup with the context requirement we look like to contextualize the focused products. Then our in-house image generation model kick in and then generate different set of the lifestyle images, meet the requirement from the prompt. Our foundation model are built on some of the most advanced generative modeling techniques, such as the stable diffusion, dream boost, etc. So this is another example that we make investment, try to empower teams at Amazon to really raise the bar in terms of generating, having the good content generating capabilities. All right, let's now move on and take a look at multimodal search. This is a very recent launched feature that offers customers the ability to search with a combination of image and text together. In this example, just imagine you get inspiration from an in-store discovery. You take a picture of this blue floral dress and go to Amazon.com, try to make a visual search. Then on the search bar, you are able to see the thumbnail of the picture you just uploaded. And meanwhile, there's a prompt asking for you to input any kind of text to narrow the search result. In this case, you are looking for another dress with a similar style, but half sleeves. And then the last picture actually show, that's the result. That's exactly what you're looking for. So backend, this functionality is empowered by our foundation model. We build a large-scale multi-model text image matching model behind the scene. That's actually pre-trained on both the product text and the image. And then in this way, this foundation model can enable our customers navigating the search functionality and altering their queries to find a variant of the product. It is also worth mentioning that sometimes the foundation model we build also offer surprising nice functionalities beyond our original expectation. So in this quick example, the customer uploaded a picture of a shampoo and a shower gel with the brand Philosophy. The top rows are from the control group from a different model. And you can see the control model, they successfully match the visual pattern of the retrieved product and the customer's query. However, the product type and the brand are inaccurate. The bottom row are the products our model enabled to retrieve. So even though for this specific product, over time, the packaging actually changed. So the visual pattern changed, but our model was still able to help successfully retrieve the right type of product type and the right brand. That is because we have built this, we found out our image encoder have this OCR capability, which was not part of the original design. Okay, this is the last example I'd like to share today. So that's the video foundation model we just developed this year. So that is pre-trained on Amazon product video datasets. For this application, ASIN face-out application on search result page, if a product has a product video that's relevant to the search query, our model will be able to just instruct this application to match the query and the relevant product videos. And then the preview will be auto-played. And if customer click on the preview will expand and show in full. The full video will be played in the product listing. So this is another great feature to help the customer getting useful product information is much easier in their search process. Well, there are many diverse applications. Let's check out how my team built the foundation models under the hood. So the process looks like this flow. We first pre-train a large language model on very large Amazon dataset. This results in a large model, we call it a base model, up to 100 plus billion parameters. And after this, we'll move on to do multitask pre-fine-tuning with many, many Amazon tasks to help this model learn different aspects of Amazon business. And as the last step, we will move on distillation to reduce the size of this 100 billion parameter model to a much smaller transformer model to fit the production requirement. Meanwhile, we also work closely with our customer teams to fine-tune the model if needed, so that we can create an application-specific model. And we also work closely with our partner teams to deploy this model into production. Well, by now I hope you'll get a high-level idea, at least, about the foundation model work, the large language model technologies we have built here at Amazon. Next, I'd like to hand over to Vijay, who's going to talk about some of the technical challenges we have got into along the way and how we work with Amazon team to solve them.
Hello, folks. Thanks, Belinda, for showing how we build a lot of delightful customer experiences. Now I want to go behind the scene. How do we use AWS to build all these applications? The first of, I want to say, like, what is M5? Like, behind the scene, like, we have a flywheel. On one side, the team is obsessing about how do we build more delightful experience for our customers. And this pushes us to go after some of the latest research, like latest model, latest techniques that we want to try out for solving these. And this flywheel builds a lot of momentum because it gets us access to different teams across Amazon, making more impact and so on. To maintain momentum on this flywheel, we have 3 challenges. One, almost all these models are compute hungry. So efficiency is very key. Next, like everyone else, like we need very specific accelerators to run these models. So bringing in any diversity there is a massive win for us. Massive win so that we can do more experiments. Number 3, people are the key here. The team behind it, we always strive to reduce their toil. Like we want to make them worry about less things so that they can focus on the customers. So I keep talking about like models and all these stuff. What are these? At the core of M5, we have a large experiment funnel. In any given month, we do about like 10,000 experiments. And some of these experiments are about fine-tuning, about pre-training, bringing a new data set, or bringing like a new algorithm, bringing a new optimizer, those kind of stuff. And all these go through a common evaluation suite, which we have built from like a lot of internal tasks. And once these experiments go over this evaluation task, at the end, we get a few M5 models. And these are the models that we take to production. So at the core, you can see, for running these 10,000 experiments a month, the core piece is how do we bin pack all these experiments on the accelerators that we have. So our choice for bin packing is AWS Batch. So we have been using AWS Batch for the last 3 years for all our experiments. So this year specifically, we adopted a new feature from AWS Batch called Fair Share. So what this allows us is, previously we had queue per work stream inside M5. So we used to have around like 10 queues, and with their own allocation, and there was a lot of manual prioritization between these queues. This led to a lot of idle capacity, just because it takes a lot of manual effort to move across these queues and stuff. So this year, we consolidated all these queues into a single fair share queue. Now it takes a couple of minutes for us to go and reconfigure the allocation for a work stream, reprioritize certain workloads, and so on. And all of these leads us to a massive win in efficiency. So this graph is basically showing you, previously with so many queues, we would end up with a lot of idle accelerators. And after we consolidated all these to a single batch queue with fair share, so the idle instances just went way down. And this was a massive win for us, like at our scale. Next, so like I was saying, all these experiments require very specific accelerators. And bringing in any diversity there for any of our workloads, like pre-training, fine-tuning, and inference, helps us to do more experiments. Basically, so our choice here is Amazon Silicon. So let me go over how we use Trainium and Inferential. So first, we still use GPUs for a lot of our experiments, but for some of the workloads where the hyperparameters are fixed, like say for example pre-training or during inference, we make a two-way door decision to move to Trainium. So here a critical piece that we look for is checkpoint compatibility. So typically a model is pre-trained, like they do a lot of hyperparameter search and finally train it for a few steps. At this point, we decide, okay, we have to train this to convergence. And we take the GPU checkpoint from there and now start training on Trainium chips. And next thing is for production. So some of our models get refreshed every week with the new data that is coming in. So for these, like there is not much changes to the model at this point. So for these, Trainium is a really good fit. To a one-time porting, like it takes about like 100 lines of code to take your PyTorch code and inject all the Neuron SDK stuff. At this point, you can start using Trainium. And And we have been able to meet all our weekly SLAs for the model refresh and so on using this. Next, the demo that Belinda was showing you, like for spelling correction. So it has been in production from 2021, and we have been on Inferentia from that point. So some of the same techniques that we use for Trainium applies in Inferentia as well. So once we know, based on analysis, like a specific workload is going to take so much fleet size and stuff, there we work on putting it to Inferentia, and it gives us like about 2x price performance ratio. So again, like the same checkpoint compatibility, train it on GPUs. Now you decide to adopt Inferentia for inference. You can port over by using Neuron SDK. And at the point, you magically get like 2x improvement. So next, let's talk about developer velocity. So people are the key in this whole system. Like if you have to do like 10,000 experiments with a small team, like the one on the right is probably a typical picture that you have seen people talking in your team. Oh, I lost my artifact, I lost my code, I lost this experiment, I did this 3 months ago, I'm not sure what happened. And so we wanted to remove all these discussions from the team. A critical thing that we want to do is don't let developers think about like reliability, reproducibility, all these problems. All these are taken care by the framework that we have. A critical thing that we did there is a global versioned immutable storage layer built on S3. This gives like a global access to all the artifacts that are part of the experiments. So when we basically like move an experiment across region, the developer doesn't have to worry about where the artifacts are and all that stuff. The next thing that when we talk with our developers is they found it very hard to jump through different systems for some of the data processing that happens to make some raw data into like a trainable examples. So this year we fixed it by doing all this stuff on the fly, because all these accelerators are co-located with very powerful CPUs. Like for example, the P4 mission has like about 100 CPU cores, and these cores can be really used to do all the data processing. So this year, this was another massive productivity win for us to do all the data processing on the fly on the CPU cores. And then all these other features like say workspace snapshotting, so that we know the experiments are never lost. And one more thing is all these deep learning workloads are going to be not that reliable. There will be always some accelerator that goes haywire and so on. So for all these stuff, the critical piece is being able to resume. So all the data processing that I was telling you, the input pipelines, the data loaders, and all these stuff is deterministic. So whenever we hit a snag, you can roll back a few steps and retry it, or change some parameters and like resume training and so on. And the final piece is when you're doing like these 10,000 experiments a month, like if you're moving at such velocity, so you need a good system to have all the job metadata. So once you have the job metadata collected over like a year or so, now you can really go back and do some analysis. Which are the work streams that is giving me massive ROI? Which work streams are driving more efficiency? And all these are input to the product team and then the engineering team to go and focus on where to focus on performance engineering, where to focus on optimization and so on. So our choice there was basically pushing all this metadata to an RDS server so that our product team can go in and do some SQL deep dives. So here in the next 2 slides, I want to go into 2 critical features that we implemented this year. The first is auto resume. So in most of the time, we would deprioritize a workload and like pause it for a couple of weeks to make way for a more higher priority job. And to these kind of preemption, we have implemented auto resume for all our workloads. So the stack takes care of doing very efficient distributed async checkpoints for all our experiments. And all these checkpoints are directly pushed to S3. So the flow you are seeing here is the typical flow. Like, so the data is there on S3 or some ETL job on Redshift, and this gets logged into the Glue catalog. From there, the data is directly streamed to the training nodes. And on the training nodes, asynchronously, the models are getting checkpointed. and again pushed back to S3. So here the critical insight here is S3 has massive bandwidth, but to saturate the network card on these accelerator missions, you need to use like a more efficient Python clients. The client that we use is the open source AWS CRT Python. It is able to saturate the network on the accelerator missions. And we are able to basically like checkpoint like 5 terabyte models seamlessly, like without incurring like a lot of storage costs because we are just sending it to S3. So next, I want to talk about the on-the-fly data processing. Almost all the techniques that we use for model checkpointing applies for data processing as well. So you directly stream in the raw data to these missions and then use the CPU cores there. In this case, like I'm showing you how we process like images on the fly and batch it in like shared memory and then send it to the GPUs. So why this is so critical for us is it reduces our time to take stuff from research to production. Because we are co-locating all these Python processing, all these data processing as like simple Python scripts that are just like right next to the model code, it allows us to like basically archive that and send it for inference pretty quickly. Previously, our developers used to like go and like muck with Spark and like how do we convert this into like something that I can do on inference and all these problems. Now everything is just Python running on the same machines where the model is being trained. And this was a massive win for us on these research to production pipeline. And again, like this pipeline is using very simple techniques like using that AWS CRT Python and doing some multi-processing on these missions. So with the reproducibility and reliability taken care, basically reproducibility as in save all the data to S3 in an immutable versioned storage and then enable like auto resume so that whenever a job fails, people don't care like because the job would just resume. So it will be just another job on batch, it will just get scheduled and it will continue training. So with these worries removed from the developer, our developers were now able to really focus on efficiency. So every job gets profiled and all these profiles, the developers are able to go and deep dive and we have pretty good isolation of compute, storage, so there is no like noisy neighbors, and all these stuff. So this enables us to run our stack at about like 90% GPU utilization. So still like the last 10% is basically we don't govern that much because we want to bias for action and let developers to try out some of the new experiments. And so quickly I want to go over give you a summary. So taking research to production remains a challenge. This year, we focused on reproducibility and reliability, and we did this by letting AWS do all the heavy lifting for us by using AWS Batch, ECS, S3, and so on. And we focused on efficiency, and we improved our ROI. So every accelerator, every watt that is spent on these accelerators is making some model progress. So we did this by adopting fair share queues and also moving a good chunk of our workloads to Trainium and inferential chips. And finally, we focused on our developers. We strive to improve the developer velocity. We did this by making them not worry about losing any data, losing any work, or my job is stuck, those kind of stuff, they don't have to worry about anymore. So today we have a stack that is replicated across like multiple regions and giving like a one facade where our developers can submit their job, and then AWS Batch takes care of routing it to the correct region and then orchestrating there and so on. And at the end, like on the other side, our developers are able to again see a single pane of glass with all the dashboard, the performance, and all the logging and all those stuff. So next, I would like to invite like James back to give some closing remarks.
Thank you, Vijay. So as you've seen, the M5 team uses a few AWS services, and in particular, they're using, again, AWS Batch to make sure that all of their GPUs are always being used. You can imagine at Amazon scale that if I have a cluster of 1,000 GPUs and they sit idle for 5 minutes, what the cost actually is for Amazon. So we, again, try to make sure that those instances are always running and utilized so we're not wasting our money. We use Amazon ECS to containerize our workloads and give us the ability to be agile, moving from region to region. We use Amazon S3 both to store the training data which our models are trained on, as well as writing the checkpoints of our models as they progress through their training cycles. AWS Silicon in the form of Inferentia and Trainium. These are, again, great options when you really want to get great performance, but also be mindful of cost. When possible, you can adapt or compile your models using Neuron to use these accelerators, and they can be well worth the effort. And in the case of M5, you can see it only took them about 100 lines of code change in order to leverage those accelerators. And lastly, they used Amazon RDS to store their metadata so that they can maintain and keep track of all of the experiments that they're running across all the ML scientists within their organization. Now, this has allowed the M5 team to vend models across Amazon. There's pretty much no part in Amazon where their foundation models have not made a measurable impact to the Amazon business. Hundreds of models have been developed and deployed. A lot of these models exceed 100 billion parameters in size. So again, the complexity is huge. They enable their internal workforce by letting them have the ability and the agility to do over 10,000 experiments every month. And today, they have over 100 developers running on their infrastructure. And they keep pushing the boundary and supporting new use cases and new modalities, as Belinda shared. Now, as you can see, the M5 team is really at the cutting edge of what Amazon is doing. And I'd like to invite Vijay and Belinda back up to the stage if any of you have any questions. And if you do have a question, please raise your hand, and if we can, we'll run down a microphone to you. But to get started, I'd love to ask Belinda, what are you most excited for in terms of GenAI and what your team is doing at Amazon?
What I'm most excited is on the customer-centric side, because in Amazon, we have this key leadership principle called the customer obsession. So everything we do, we try to work backward from an opportunity that can really innovate on top of our customers. So you can see a lot of the examples, the application I just shared, is all centered around that. So seeing our research from ideation to deployment that can generate true delightful customer experience is something really excites me every day.
Great. We appreciate all of you taking the time to spend this hour with us. We'll be outside if you have any ancillary questions. We encourage you to take the survey so we can improve and be with you all next year. But with that being said, thank you all for attending.
Thank you.
Thank you.